notation. So the one that is probably my favorite is with extra sets of parentheses. So it looks like this, like an F and then a parenthesis. And then it'll have a G and then a parenthesis. And inside it'll have an X. And then I'm just going to close both parentheses. Okay. The way you would read this is F of G of X. So F of G of X. Don't have to write this if you don't want to, but you could also write this as F composed with G of X would be another way that you could word that. I usually just call it F of G of X because it's less words to say. But there is another notation which I have underneath here, and the F of G of X, like I just put in this big box here. They also call this, like sometimes they call it fog notation, but and this is important. This is not a multiplication symbol. It's like a little open circle. So don't confuse this with multiplication because we did some operations with multiplication in the last lesson, but it's a little open circle. That is a composition if you see that notation. It's the same thing, F of G of X or F composed with G of X. Like I mentioned to you, I'm going to try to use both. My preference is this one because that's how I learned how to do it, but you can use either one. If you have this notation, the way you work with it is you work from the inside out. So you would do whatever function is inside there. So I do the G function first, and then you're going to plug that into the F function. It's like two problems in one when you do these questions. If you have this notation here, the F of G of X with the little open circle, like I said, fog notation, they call that sometimes. Whatever's closer, so the G, whatever's closer goes first, and whatever's farther away is going to go second. So you can use either one. I'm going to try to write both of them for you guys so you can see how this works. Now, I'm going to grab some different colors to go through these problems today. Now, very similar throwing things to what we did on Friday. If you have a number in the parentheses, the answer should be a number. If you have a letter in the parentheses, the answer will be some kind of expression. So all these first couple questions we're going to practice here, these will all have number answers. So I'm going to rewrite this first one just to show you both notations. So this says F composed with G of 6. I could also write that as F of G of 6. Okay, first thing you're going to do is you're going to do G of 6. Okay, so whichever one is, if you like this notation inside out, G of 6 goes first. If you like the other notation, whatever's closer to the number goes first. We're going to do G of 6. Just go up to your little directions real quick, and the G of X function is just X minus 3. So I would do 6 minus 3, which would be 3. Okay, I know this is weird, but it's basically just like a little substitution then. So now I know G of 6 is 3. So to do the rest of the question, I just take that 3 and plug it into the F of X function. So it's like two steps, two problems in one. You do G of 6, then whatever that is, that number's 3 here, you just substitute that in, and that gives us F of 3. This will be our final answer, and the F function is 5 times that lovely X value plus 4. So this would be 15 plus 4. So ultimately my answer to the question is 19. It's not bad to do, it's just kind of weird. If you look at my second problem, let me just write this in the other notation. So this is G of F of negative 7, or G composed with F of negative 7. If I use the little parenthesis notation, it would be like G parentheses F of negative 7 and then close the parentheses. So this one, the F function goes first, inside out or whatever's closer to the number. So I'm going to do F with a negative 7 plugged in. So it'd be 5 times negative 7 plus 4. So I'd get negative 35 plus 4, which is negative 31. So that's F of negative 7. So to complete the problem, whatever that is, this is F of negative 7. you're just going to put that into the g function. It's like a little substitution. So I'm going to do g of negative 31. Now, in the rule up here in the directions, it's just the x value, which is negative 31 here, minus 3. So just subtract that, you get negative 34. And then there's my answer, negative 34. Okay, I'm going to do one more. Now, this one is to compose a function with itself, which you can do. You're basically just going to plug these numbers both into the same function. So the notation here would look like f of 8 if I was working on using the parentheses, or if you like the little fog notation, use that. So I do f of 8 first, so it'd be 5 times 8 and then plus 4, which should just be 40 plus 4, so 44. And then this one just a little different than the other two because we're going to actually substitute this in. F of 8 is equal to 44, and then you're just going to plug it back in to the exact same function. So it'd be 5 times 44 plus 4. I'm going to grab my calculator real quick because I don't know what that is off the top of my head. So I'm going to get 224. Does anybody have a question? It's not horrible. Okay, I'm going to try some a little bit different function rules in this below here. So these guys are a little bit more complicated. So this first one, g of f of negative 10. So I could do it, or g composed with f of negative 10, if you like that notation better. Now, f of negative 10 here. So I'd have in my absolute value 3 times negative 10 and then plus 2. So inside your absolute value, you're going to multiply those two guys together. That's going to give you negative 30. And then once you get whatever's inside the absolute value down to one number, then to actually take the absolute value after you get that down to one number is what you should do. So that's just going to become 30. Absolute value makes everything positive. And ultimately, you don't have to write out all these steps. I just want to show you where it comes from. That should be 32. All right, once you got that, that's what f of negative 10 is equal to. So you're just going to substitute that in for the f of negative 10. So then, to answer the question, we're going to plug 32 into that lovely g of x function. Now, parentheses, square root acts like a grouping symbol like parentheses. So when I plug the 32, it's the square root. The whole thing's under square root. 32 plus 4 would be how I would plug that in. Before you take the square root, you should add those numbers together and then take the square root after you have it down to one number. So just keep that in mind. So 32 plus 4 is 36. You guys know square root of 36? 6. So there's my answer to the question. Is anybody having a question? Okay, I'm just going to have us practice a couple more and then we'll do kind of a weird one at the bottom of the page. All right, this next one is f of g of 77. So this one we're going to use the g function first. So g, we're going to plug in 77. So again, the square root acts like a grouping symbol. Don't just see the 4 and be like, oh, the square root of 4 is 2. No, because if you have adding there, you need to add first and then take the square root as your last step. Get that down to one number. That is actually 81, which should be a nice perfect square, so that's 9. And then once I have that, that's what g of 77 is equal to. So you're substituting that in. G of 77 is equal to 9. So, bless you, ultimately we're going to do f with a 9 plugged into it. Now, when you have an absolute value, if the number's already positive, it just stays positive. So 3 times 9 is 27, and so we would just have 27 plus 2. So 29 would ultimately be our answer there. And then I'm going to do one more. This is g composed with g. So we're going to plug both of these into the g function. So g of 3,596. And I'm pretty sure this will be a nice number when we get done, but let's just check. So 3,596. If I plug that in, don't forget you want to add the 4 first and then take the square root. So that would be the square root of 3,600. Anybody know what that is? 60, perfect. Okay, then you're going to grab the 60. The weird part of this one, you're just composing a function with itself, so it just means you're going to use the same function rule twice. So then I'm going to do g of 60. So we would have 60 plus 4, add first, so 60 plus 4 is 64, and then take your square root once you got that down to one number. Okay, so square root of 64? 8. Excellent. So 8 is the actual answer to the question. These problems are not bad, it's just basically you have to do kind of 2 problems in one step. Is anybody having a question? Okay. Anybody have any idea how they would maybe do the problem here at the bottom of the page? I have this, you would read this as f of g of h of 2. Yeah, this is like 3 in 1. So just work from the inside out. So this, do h of 2. Now just look up here and make sure you're using the right function rule. So this would be 2 squared plus 1, which is going to be, what, 4 plus 1 is 5. Okay, then the next one you see in that list is g. So then we would do g of 5. G function is just 3 times x, so it would be 3 times 5, which is 15. And then the one on the far outside is the f, so we get plugged into that last. So then I would do f of 15. So I'd have 2 times 15 minus 1, which would be 29 would be my final answer. We just got to basically kind of work through several steps to get to it. Is anybody having a question? Most of the problems are just going to be 2 functions composed together. I'm pretty sure the reason I have this on here is because we have a bonus question on the test that looks like this. So I wanted to make sure I showed you guys. Okay, now I'm not going to lie to you. These ones on the back, some of them can be really quick and easy, and some of them can be like really tricky. Not necessarily tricky, but like the algebra's maybe a little bit more time consuming. Okay, now I have at the top, if you look, like kind of like 2 columns basically, but they're going to use exactly the same 2 function rules, but I'm showing you there's a difference with which function goes first when you do the composition. Okay, let me write the notation here real quick for you. So this is f composed with g of x or f of g of x. The weird part here is we're just using g of x. Okay, so g of x is equal to x minus 3. Okay, the way this works, if you've got an x, you're literally going to take, so that's what g of x is equal to, right, that expression. I'm going to take that whole thing and I'm going to put that in place of x in the other function, right? So if I do this, f of g of x, like the g of x, the x minus 3, everywhere you see an x in the f of x function, which is just 5 times x, I'm just going to replace that with the x minus 3. This is not necessarily 2 problems in one. It's like which expression are you plugging into the other. So g of x is equal to x minus 3. So that whole expression, x minus 3, replaces the x in the other function rule that they give you. And then once you actually put it in, it's usually not bad to do. We might have to do like a little distributive property or something. This is 5x minus 15 plus 4. And then I can combine some like terms here. This would be 5x minus 11. So that expression would be my answer. Now, if it goes the other way, so this one is the same 2 functions, but this is f of g of x. All right, so in this scenario, we're going to go the other way. I'm going to plug the f of x function into the g of x function, which this one's a little bit weird. Actually, let me write a little step here. So we have x minus 3. What I'm doing is I am replacing x with the 5x plus 4, and then we still have the minus 3. In this situation, the x doesn't have anything in front of it, so there's really nothing to distribute or anything like that. So I can combine some like terms. This would be like 5x plus 4 minus 3, so it would be 5x minus 1. So it's just a little bit different when I go a different direction. But you're just replacing that entire expression in for x. So those are two that just have basically linear function rules. I'm going to do one with a quadratic in the next set. And you'll see one of these will be way harder than the other. All right, so this is f of g of x. Okay, so in this case, the g of x goes first. So that means I'm going to take and I'm going to plug this entire expression goes in place of the x. All right, so this one started out and it was 3x, but instead of x, I'm going to substitute that x squared plus 2x minus 8, and then don't forget to write the rest of whatever the function was. So it was 3x minus 1, so don't forget the minus 1 part after you plug that in. Then it's just a couple steps. We're just going to do a little distributive property. So we got 3x squared plus 6x minus 24, then minus 1. 3x squared plus 6x minus 25 would be my answer. Don't try to factor or do anything like that. When you're done, just leave it in standard form. That's the answer. Okay, now number 4 on this back side represents like the most horrible problem you would probably have to do in this entire unit. And the reason this is so tricky is because we're going to plug the f of x function into the g of x function. And the reason it's so tricky is if I'm plugging into a quadratic, you have two different places that you have an x. So when I do this, in place of the x squared, you're going to do 3x minus 1. That whole thing would be the x squared piece. Then it's plus 2 times x, and again, I would have to plug in that entire f of x expression, the 3x minus 1, and then we have the minus 8. And this, I promise, it's not that bad. Just don't distribute that exponent. Don't forget, on that first term, if you distribute that exponent, you will completely miss out on the middle term for that quadratic. So make sure you do like a little FOIL or box, whichever one you like better. I'm just going to do a FOIL. So I should get, let's see, 9x squared minus 3x minus another 3x plus 1, which is 9x squared minus 6x plus 1. And then I would do a distributive property. I'm just going to kind of bring it down here. 2 times 3x would be 6x. 2 times negative 1 is negative 2. And then I had that negative 8 on the bottom there. Alright, just see if you can combine like terms. In this particular problem, and this doesn't always happen, this is just like a fluke on this one, okay? I don't want you to think this always happens. I do have a negative 6x and a positive 6x, so those would cancel each other out when I'm combining like terms. And then in terms of plain numbers, you got 1 minus 2 minus 8. So if I put all those guys together, that would just be negative 9. And you can factor this, but don't be tempted. Just leave it in standard form. We don't want to factor anything. We're just multiplying it out as we plug in the function rules. Is anybody having a question? Okay. Now, this last one we're going to do is a little bit weird. I've got a quadratic, but I've also got a square root. So I'm going to show you guys this one. So I haven't been writing this. This is f of g of x, if you like this notation better. And this is, I don't know, I put an extra parenthesis, g of f of x here. But on the first one, I'm going to plug this entire square root in place of the x squared. Alright, this looks a little weird. So instead of x squared, I'm just going to use parentheses. You'd have this square root x minus 9 squared, and then the plus 9 would be on the outside. Does that make sense? Like I took the whole square root, it goes in place of the x squared. So like here, this was x squared, I'm replacing it with that. Does anybody know what happens in that first term? Like algebraically. If the whole thing's under a square root and then it's squared. Cancels. Yeah, this is just a weird question. So the square root and squared cancel each other out. Now, you'd still be left with the x minus 9, and then we'd still be left with that plus 9 on the outside, And so this actually just simplifies to be x. All right, the other one, if I go the other way, so this is g of f of x. That means I'm going to plug this mess. Sorry, I didn't type these out twice on this one. But I'm going to plug that in for x in the g of x function. So to do that one, and I have I'm just going to kind of make a big square root here. All right, so in place of x, I'm going to put x squared plus 9. And then we also had a minus 9 under the square root. So I'm replacing, this whole thing was just to represent x, but in its place I put x squared plus 9. Now there's nothing in front of the x or anything like that in that rule. So if you want to just drop the parentheses, totally legal there, it would just have like a 1 in front of it, so it wouldn't change anything. Now, if you're going to try to take a square root, you should get everything down to one term if possible. In this example, the 9 and the negative 9, both under the square root, they would actually cancel each other out. So all I would have left would be the square root of x squared. Does anybody know what that is? X. So it cancels out. So actually both of these end up being x. And that's going to lead into what we're going to actually talk about tomorrow. So don't worry about it too much, but it's totally fine to just get that simplified down to an x.